Okay, let's move on to section 8. And we're trying to find the molarity of NaOH. So we're acids and bases. So we're using the titration equation, which is this. So MAVA equals MBVB. Here's what I need to check for my acids and bases first. Do I only have one H? Yes. Do I only have one OH? Yes. Beautiful. I can just set it up. So the molarity of the acid is 3.0. The volume of the acid is 50.0. The molarity of the base is what I'm trying to find. The volume of the base is 30.0. So 50 times 3 is 150. So then I divide both sides by 30, and the molarity of the base 150 divided by 30, I can do that one in my head, is 5 M molar. Here's our next one. What is the molarity? So let's set it up. MAVA equals MBVB. Let's look. Oh, this is not a titration. You see this? What is the molarity? So what's another way I could find molarity? So I started looking. I was like, wait a second. It's just a base. There's no acid here. So wrong formula, and that's okay. That's part of the process. So let's look here. I made an assumption. That's what I get for assuming. So molarity equals moles over liters. So moles is 2.0 moles divided by 4.0 liters, and so the molarity equals 0.5 molar. Okay. Oops, turn the wrong way. All right, a couple more questions. In this reaction, the Bronsted Lowry acid in the forward reaction. Okay, so Arrhenius acids donate, they have H plus as their only positive ion in solution. Arrhenius bases have OH negative as their only negative ion in solution. But a Bronsted Lowry base is just giving away H pluses. So they're H plus donors, and bases are H plus acceptors. So there's two ways to think about acids and bases, but this is Bronsted Lowry. So I'm looking for the acid in the forward reaction. So that would be the donor. So which one is giving up an H plus? So find where the H goes. So look, see this? The H goes from here to here. So that means this HCl has to be the acid. Now, we're going to do the same thing in this reaction. So let's follow the H. Where does it go? So it goes from here, right, to here. Nope, the other way. It goes from here to here. So in the forward reaction, this is the acid, this is the base, but I'm looking in the reverse. So where is it going when I look this way? So it's going from here to here. So this is the acid and this is the base. So Cl negative. It's got to be something on the reverse side. Okay? And so this is called, so this is the conjugate acid and the conjugate base. So if this is the acid and it gave up an H, right, on this side, it's the conjugate base. So that's kind of another way to look at it. But that is the end of section 8.